Let's review for the final exam. Let's get started. Question 1, let's solve the equation 4x plus 4 minus 2 times the quantity x plus 1 equals 9x plus 6. The first strategy is to get rid of the parentheses. So let's distribute. We have 4x plus 4 minus 2x, and negative 2 times 1 is negative 2, and that's equal to 9x plus 6. The next step is to collect like terms. I can add 4x and negative 2x together, that's 2x. 4 and negative 2 together is a plus 2, and that's equal to 9x plus 6. The next step is to subtract 2x to both sides, and we're going to also subtract 6 to both sides to isolate the x variable. The 2x and the negative 2x cancels out. The 6 and the negative 6 cancels out. And we are left with negative 4, because 2 minus 6 is negative 4, and that's equal to 9x minus 2x, which is 7x. Let's divide both sides by 7. And so x is equal to negative 4 over 7. This is our solution for question 1. Question 2. Margaret drove to a business appointment at 80 miles per hour. Her average speed on the return trip was 70 miles per hour. The return trip took 1/7 hour longer because of heavy traffic. How far did she travel to the appointment? It's convenient that they gave us a table and they filled in some information for us. In the morning she drove 80 miles per hour, and on the return trip she used a speed of 70 miles per hour. The time is unknown for the trip, so we leave it as x. And we know in the afternoon it took 1/7 hour longer. That's why we have x plus 1 over 7. I want you to recall the distance is equal to rate times time, and we'll use this to find the distance. We know the rate is 80 and the time is x. So multiply that together, I should get 8x. For the afternoon, we have the rate is 70 and the time is x plus 1 over 7. So the distance would be 70 times the quantity x plus 1 over 7. Now, in order to solve this, we have to come up with an equation. What can we say about the distance in the morning and the distance in the afternoon? They should be the same. 80x should be equal to 70 times the quantity x plus 1 over 7. Now we can solve for x. Let's distribute the 70. 80x equals 70x plus 70 times 1 over 7 gives me 10. Now I could solve for x. Let's subtract 70x to both sides. 80x minus 70x is 10x, and we have 10 on the right. Let's divide both sides by 10. X equals 1. But this is not our solution. X does not represent the distance that she traveled. This is x equals 1. This represents 1 hour. So to solve for the distance that she traveled, we're going to plug this x equals 1 back into our equation here. We want to find the distance. We know the distance is equal to 80 times 1, and so we have this is 80. So her business trip was 80 miles away from her home. In question 3, we're going to divide complex numbers. We have 6 plus 9i over 5 plus 2i. The strategy is to multiply the top and the bottom by the conjugate of the denominator. The conjugate of the denominator would be exactly the same thing except with a opposite sign in the middle. So instead of a plus, we're going to use a negative. This is 5 minus 2i on the top, and we'll use the same thing on the bottom, 5 minus 2i. For the top, we'll have to FOIL. 6 times 5 is 30. 6 times negative 2i is negative 12i. 9i times 5 is 45i. And 9i times negative 2i is negative 18i squared. That's over. And for the bottom, I could use the shortcut. Remember, when you're multiplying conjugates, recall a plus b, a minus b. That's just a squared minus b squared. So I can just multiply the first with the first and the last with the last to figure out what this is. This should be 25 minus 4i squared. Now we also need to recall that I squared equals negative 1, so I can replace all of these I squareds with a negative 1, and so we're going to simplify this. 30 negative 12i plus 45i is a positive 33i. Negative 18i squared, remember I squared is negative 1, so this is actually a positive 18. And on the bottom we can simplify negative 4i squared. I squared is negative 1, so this becomes a plus 4. We could collect like terms. 30 plus 18 is 48. And we have the 33i on the top. 25 plus 4 is 29. But this is not a good enough solution for the computer. You need to give it in a specific form. So let's rewrite this as 48 over 29 plus 33 over 29i. They want your answer in that nice standard form, a plus bi form, and that's a good solution. So make sure you take the extra step and convert it to a plus bi form. Question 4. Solve the equation by the square root property. This means I'm going to take the square root of both sides, but don't forget when you do that you have to include a plus or minus. On the left side, it just simplifies to z plus 7 because that square term cancels out with the square root. And so we have plus or minus the square root of negative 64. Recall we can extract the square root of negative 1 out to the front. This is equivalent to plus or minus I times the square root of 64. And we can simplify the square root of 64. That's just 8. So we have z plus 7 equals plus or minus 8i. We now can subtract 7 to both sides. And when you subtract 7 to both sides, do not subtract it behind the 8i. Always put it in front of the plus or minus so we don't accidentally take it away from 8. Z simplifies to negative 7 plus or minus 8i. So this is our two solutions. The first one is negative 7 minus 8i, and the second is negative 7 plus 8i. Question 5. Let's solve the equation x to the fourth plus 2x squared minus 35 equals 0. This looks kind of like a quadratic. It has an x to the fourth. So I can use u substitution. So let's figure out what the u is. I want to rewrite this so it's a power of 2. And I know x squared squared is going to give me x to the fourth. So that gives me an indicator of what my u is going to be. I'm going to replace all these x squareds by the letter u. This is using u substitution. So we have u squared plus 2u minus 35 is now equal to 0. And I know how to do this. I can factor. We can use the diamond method, negative 35 on top, 2 on the bottom. And now let's figure out the two numbers. So 5 and a 7, but I need to add up to a 2, so let's use negative 5 and positive 7. This factors as u minus 5 times the quantity u plus 7. And that's equal to 0. That's great. Now I can set each of these equal to 0 and solve for u. The first one is u equals 5, and the second one is u equals negative 7. But our solutions are not 5 and negative 7. You have to convert it back to x. X squared is equal to u. So let's replace these with x squared and x squared here as well. Now we can solve for x. We'll take the square root of both sides. Don't forget that plus or minus when you take the square root of both sides. And x is equal to plus or minus the square root of 5. That's our first two solutions, a plus and a negative root 5. And the second one here is x equals plus or minus. There's a negative in the radical, so I'm going to take that out. That's I root 7. So these are two other solutions, negative I root 7 and positive I root 7. Question 6, solve the quadratic inequality. Write the solution set in interval notation. First step is to try to factor this. We have negative 15 on top, negative 2 on the bottom, 3 and 5 looks good, so it's 3 and negative 5. This factors as x plus 3 times x minus 5, and that's greater than 0. So these two equations or inequalities are the same. Now for a quadratic inequality, we always start by looking for zeros. Let's set x plus 3 times x minus 5 equal to 0 to figure out where it touches the x-intercepts. So we have x equals negative 3 or x equals positive 5. These are my zeros. After you find your zeros, make a number line. We have negative 3 and we have positive 5. Negative 3 and positive 5 are going to be open circles. The reason they're open circles is we have a greater than 0. So these values at negative 3 and positive 5 are exactly 0, so they're not included. We want to be strictly greater than 0. So open circles for these. And now we'll have to pick some test points. We'll pick a good number to the left of negative 3. I'll pick negative 4 to test. And then we'll pick a good number between negative 3 and 5. I'll pick 0 to test. And a good number to the right of 5, I'll pick 6 to test. And when you plug these numbers in, you can plug it back into the original equation, or you could plug it back into your new equation that you made here. It's up to you. So I'm going to use the original. We have negative 4 squared minus 2 times negative 4 minus 15. And I want to figure out if that is greater than 0. I got this as 9, and it's clearly greater than 0, so this is a true statement. That means I'm going to shade everything to the left of negative 3. Now let's check 0. Is 0 squared minus 2 times 0 minus 15 greater than 0? This one's negative 15, and that's not true. This is false, so don't shade in the middle. Now we'll plug in a 6 into the original equation. We'll plug in a 6 into the original equation and see if this is true. We have 36 minus 12 minus 15. Is that greater than 0? It's a 9. 9 is definitely greater than 0, so this is true. We shade to the right. So the graph is nice because it allows me to read off the interval notation. Here's our answer. It goes to the left, negative infinity to negative 3, parentheses because it's an open circle, union, 5, again open circle, then we have infinity. So this is our answer in interval notation. This is what we're going to enter. Question 7. Write an equation of a line through the points negative 4, negative 3 having slope 2 over 11. Give your answer in standard form. Recall standard form is ax plus by equals c. So we need to make sure our answer looks like that at the end. Recall the formula y minus y1 equals m times x minus x1. This is the point slope formula. So let's use it for the problem. We have negative 4 and negative 3. Those are x1, y1s. And the m is that 2 over 11. Let's plug it in. Y minus a negative 3. Don't forget there's a double negative. 2 over 11 times x minus a negative 4. Again, there's a double negative. Be careful with the signs. We have y, and the double negative becomes a plus 3 equals 2 over 11. And then we have an x plus 4. Let's distribute it at 2 over 11. Y plus 3 equals 2 over 11x plus 2 over 11 times 4, that's 8 over 11. Now this is not standard form. We have to get rid of these fractions. So what I like to do is I multiply everything by 11. What I need to do is multiply everything times 11 just to get rid of all those fractions. And we have 11y plus 33 equals, well, these 11s cancel out, you just get 2x. These 11 cancels out, so you just get 8. Now we can set it in that standard form. To do standard form, we'll have to subtract the 2x to both sides. And I'm going to subtract 33. We want the x in the front first, so this becomes negative 2x plus 11y equals 8 minus 33 is negative 25. And so this is our standard form. But typically in standard form, we like the leading coefficient to be positive. So at the very last step, we divide everything by negative 1 just to make the leading coefficient positive. So this is 2x minus 11y equals positive 25. This is in that standard form that they want. Question 8. Let's graph the piecewise defined function below. We have f of x equals negative 2 minus x if x is less than or equal to 1, and negative 3 plus 2x if x is greater than 1. First step is to look at our intervals, and we want to check values that are less than or equal to 1. So we'll start with x equals 1 first, and I'll plug it into negative 2 minus x. This gives me negative 2 minus 1, and that's equal to negative 3. So let's plot the point 1 comma negative 3 on the graph. And I know this is going to be a closed circle because of that inequality. It's a less than or equal symbol, so it must be a closed circle. So let's check other values that are less than or equal to 1. So let's check x equals 0. Negative 2 minus 0 equals negative 2. So we can plot 0 comma negative 2. We'll do one more. Let's say x equals negative 1. For x equals negative 1, we have negative 2 minus a negative 1. This becomes a negative 1. So here is what our graph looks like. It's going to be a line that goes, a general sketch of what our graph looks like. It's part of a line here, and it's going to go straight towards this direction. It's going to be a closed circle at this endpoint. Now we need the other half of it. We're going to check values that are greater than 1. But I'm going to also plug in 1, but not include it as part of my graph. So let's check x equals 1, but this time we're going to plug it into negative 3 plus 2x. Negative 3 plus 2 times 1, that's going to give us negative 1. So at x equals 1, we have the ordered pair 1 comma negative 1. 1 comma negative 1, but this is an open circle. I know this is an open circle because of this inequality. So we still have to test that endpoint. At 1, we're going to get 1 comma negative 1. Let's check another value, but we're going to pick something greater than 1. Let's pick x equals 2. We get negative 3 plus 2 times 2. This is negative 3 plus 4, which is positive 1. So we get a positive 1. So the ordered pair is 2 comma 1. And so if you continue the graph, you will get that this is another line that goes up. Just start plotting points, and just be careful at the end points. If it's less than or equal, make sure it's closed. If it's greater than, make sure it's an open circle there. Question 9, let f of x be equal to x minus 1 and g of x equals x squared minus 3. Find f of g of negative 6. What I like to do first is I always try to find f of g of x first. This means plug in the entire function g into the function f. We're going to plug this into the x for the f function. This is equal to x squared minus 3 minus 1. And this gives me x squared minus 4. This is f of g of x. And then I can use this to find f of g of negative 6. We're going to plug in a negative 6 into the x. So this is negative 6 squared minus 4. And that simplifies to 36 minus 4, or 32. Our solution is 32. Question 10. For the given equation in the graph of the quadratic function, let's do the following. Complete parts A through E. First step is to find the vertex. The vertex, if I compare it to the vertex form, x minus h squared plus k is h comma k. So our vertex is positive 4 and negative 9. And that completes part B. 4 comma negative 9 is our vertex. Let's plot that point. 1, 2, 3, 4, and go down 9. This is the point 4 comma negative 9. Now we can look for the y-intercepts. To find the y-intercepts, we're going to let x be equal to 0. So I want to plug in a 0 for the x. Y equals 0 minus 4 squared minus 9. And if you simplify this, this is just 7. So this gives me the y-intercept is 0 comma 7. Let's plot 0 comma 7. Now let's plot the point 0 comma 7 on the graph. Here's the point 0 comma 7. And we know at the vertex that's where the axis of symmetry is going to be, at the vertex. So you can clearly see that this is a vertical line at x equals 4. So that's our axis of symmetry, x equals 4. Make sure you write it as an equation, x equals 4. And now we can find the x-intercept. 0 equals x minus 4 squared minus 9. And now I have to solve for x. Let's add the 9 to both sides. 9 equals x minus 4 squared. And we can take the square root of both sides. Don't forget that plus or minus. So we have plus or minus. The square root of 9, that's 3, equals x minus 4. Add the 4 to both sides. X equals 4 plus or minus 3. So we got two solutions for x. X could be equal to a 1 or x could be equal to a 7. And that means we have 1 comma 0 and 7 comma 0 as our x-intercepts. Let's plot those on the graph. Here's 1 comma 0. And here's 7 comma 0. So we do have a parabola and it does face up just like we predicted because the leading coefficient is a positive 1. So it should face up because the leading coefficient is a positive 1. Now we can look at the domain. It goes to the left forever, to the right forever. That's the domain. For the range, it goes down all the way to negative 9. And we're going to use a square bracket. And it's going to go up forever and forever. So that's the range. So we have the domain is negative infinity to infinity. The range is a square bracket negative 9 comma infinity.